Okay, been a little bit of a gap between my last video and this one, but here we are. We are still working on chapter 12 of the first year book, Differentiation. Mixed exercise at the back. Question 23. So diagram shows part of a curve which has y equals 3 plus 5x plus x squared minus x cubed. Okay, the curve touches the x-axis at A and crosses the x-axis at C. The points A and B are stationary points on the curve. Show that C has these coordinates. They've given us a little picture, which looks something like this. It comes down here, it touches there, crosses there and goes there, and they are saying that this point here is A, this point here is C. They have marked a B, which I presume we're going to use later, and they want us to show that this point here is 3, 0. Okay, if that is 3, 0, that means that the x equals, wrong colour, x equals 3, which means x minus 3 equals 0, making x minus 3 a factor. Okay, so if we have a factor, we can put it in, and using the factor theorem, we can say that when we do f of 3, it should equal 0 if it is a root, if it's a factor. Okay, so y equals 3 plus 5 times 3 plus 3 squared minus 3 cubed. 3 plus 15 plus 9, 27 minus 27. I think that's correct, isn't it? Check on the calculator, always worth the check. 3 plus 15 plus 9, yes, is 27, minus the 27 is equal to 0. Okay, so that's our part A done. Part B. Okay, 1 mark, so yes. Using calculus and showing all of your work in, find the coordinates of A and B. So we need to find the other root here, and we need to find B there. So we are going to start with doing a division of x minus 3 into here, and we are going to divide it into the original equation. I'm just going to write it in the opposite order. Minus x cubed plus x squared plus 5x, getting the signs right, plus 3. Okay, start doing the division on that then. So what do we need up here? We need a minus x squared, so that minus x squared times x gives us minus x cubed, and that will give us plus 3x squared. When you do the sign changes on that, you will end up with 0. That's become a minus, so minus 2x squared, and we bring down the 5x. Okay, x into minus 2x squared is going to be minus 2x, so that gives us a minus 2x squared and a plus 6x. Okay, a bit more space. Do the sign change. That becomes a 0, minus 6 plus 5 minus x plus 3. So I want a minus x up here. No, I don't want a minus 1. Done the x's. Minus 1, so that gives us a minus x, minus 3, which then gives us the 2 pluses in there. Okay, so we have x minus 3, and we have minus x squared minus 2x minus 1 is equal to y. Now I've just realised it said use calculus to show your working. I'm not using calculus. I was about to go and factorise this out and make it a plus minus and all of that. I think it's like 1 plus x minus x, something like that. But I haven't used any calculus yet. So we should probably come back up here and start with y equals 3 plus 5x plus x squared minus x cubed. I was solving it like, I don't know, chapter 2 or something when we did polynomials. So dy by dx, differentiate it, the 3 disappears, drop the power, that becomes a 5 plus 2x minus 3x squared. Now what we're going to do is we're going to solve that equal to 0. So with that equal to 0, 5 plus 2x minus 3x squared, I'm going to put it straight into a calculator so that I can get the answers coming out. We're assuming, so what am I doing? That looks like the wrong thing. Menus on the calculator, menu equation function number A, 2 polynomials, 2 degrees, and we've got minus 3 as a number, plus 2 and 5. And it tells me x equals 5 over 3, and it also tells me x equals minus 1. So that's the point that it's at 0. Therefore, I can say, what did it want to do? It wanted to find the coordinates of A and B. So remember the graph that they gave us? That's got to be x equals minus 1. Okay, and this must be the 5 over 3, which of course is like 1.6, and since this is 3, okay, so since we're doing coordinates, I can put in this as coordinate A with an x number of minus 1 and 0, because we were told it touches the y-axis, and then for this one we just need to put it into f of 5 over 3 will equal to find out what this maximum b is. Okay, what were we on? Not 3 but 5. 3 plus 5 times 5 over 3 give myself some room, plus 5 over 3 squared minus 5 over 3 cubed, which becomes 3 plus 25 over 3 plus 25 over 9 minus 125 over 27. When you square and cube all of those things out, I think I'm going to leave the fractions for someone else to do, and we can quickly come in here onto the calculator and do 3 plus 25 over 3 plus 25 over 9 minus 125, that's how it goes, minus 125 over 27. and we get 256 over 27, which is 9 13/17. 9 13/27, not 17ths. So that puts point B as 5/3, and I'm going to leave it as the 256 over 27. Okay, so there's your point B, there's your point A, -1, 0. Okay. Okay then, let's have a look at question 24. The motion of a damped spring is modelled using this graph. Very nice. On a separate graph, sketch the gradient function for this model. Choose suitable labels and units for each axis and indicate the coordinates of any point where the gradient function crosses the horizontal axis. Okay, let's have a little look at what they've given us then. So we've got a displacement, and we've got some sort of dotted line coming out of here. Okay, and then we've drawn a graph, or they have more to the point, which comes up and over. And I don't think it comes quite so far down. And it's doing something like that. Okay, and then we've got time in seconds coming across here. So this one is time in seconds. This was displacement in centimeters. And we were told that we had a time here of 0.5, and we were told we have a time here of 1.2, and we were told that we have a time here of 2.1. So they want us to draw a matching graph, but in this case the gradient function of it. So what do we know about that gradient function? So as the gradient comes across, it's going to be working on time, just like we have been doing here. Okay, so we will take these down, and we'll have 0.5, we will have 1.2, and we will have 2.1. Okay, and they are going to be the time functions. Okay, so that is still time. Okay, now as we come across here, what's going to happen to the gradient? At the moment, we've got a nice positive gradient, which is then coming to 0. And then as it comes down here, we've got a negative gradient. Okay, think about a tangent line that's sitting on it, yeah. And as it goes past this point here, it then starts curving back round until it gets to the 0. Okay, and then same again, same again. So it will be coming through each of these at this point. Basically, it's going to come up positive on here, and just at this point it goes to 0. And at that point it becomes a negative number, so it's all positive. It's got a positive number, and it's coming in here. So at the moment, up here somewhere is a positive value for the gradient. And as I come in here, it gets to a, whatever it's called, the point of 0, so we get the flat point. Then as it comes down here, we've got a negative gradient. So as we come through here, okay, we've got a negative gradient, and that negative gradient starts to ease off and come back for 0.1 at, or 1.2 to be at 0 again. And again, you see we've switched to being into a positive gradient, okay? And so then again, it comes over here and comes through there like that, and it looks like it's curving off that way, like that. Okay, so that's what we're going to look like with a bit of a phase shift in there. So the only thing we've got left to do on that is to decide what is y. Okay, so we know this is y of 0. Okay, they didn't mark inflection points of here and here, these points where it kept changing from 0. So that would be here and here, I think. So what do we want for this? It's going to be the change. It's going to be the change in centimeters given the change in time. So if we've got a change in displacement, we are going to be calling that, this feels like a distance speed, isn't it going to be? I can't quite think it through. I think it's distance speed. Okay, speed or velocity, really. Okay, so as that comes in there, yeah. So this is now velocity because it's centimeters per second. It's the change of time over there. Okay, and that's it. They wanted units, we're still in seconds on that. Okay, pretty ugly looking thing, but that's about all it needs to be. Okay, right, and so as it comes up, doesn't quite get to that point of the axis. All right, so question 25 then. Question 25, let's have a look. Okay, so the volume V centimeters of a tin of radius r is given by the formula. So volume is equal to pi times 40r minus r squared minus r cubed. Okay. And if anyone's got the book, look at question 28 because they've used the same thing. Find the positive value of r for which dv by dr equals, so equals 0. So dv by dr, differentiate this. We're going to have pi 40 minus 2r minus 3r squared. Okay, so there's dv by dr, and then they want to know what the value of r is when we have it in the positive. Okay, so the pi will disappear to begin with, and then we are left to solve this. And again, I'm going to go straight in. I could use the quadratic formula, but I'm just going to use a calculator to do it. Okay, because you've got the technology, so we might as well use it. Okay, so r equals and r equals. We're expecting two answers on it. Okay, so we've got -3, and we've got -2, and we've got 40 for the ABC values. Putting it in, we get R as 10/3, and we also get R as -4. They asked for the positive value, so we can disregard this. Disregard that. Okay. Find the positive value and find the value of V which corresponds to this value. Okay, so now that we know R, we need to substitute it back into the original equation. Okay, so we are going to have, I'm going to write it in as f of 10/3 is equal to pi times 40 times 10/3 minus 10/3 squared minus 10/3 cubed. So we end up with pi over, what's that, 400/3 minus 100/3 minus 1000 over, oh no, not 3 there, 9, 27. Okay, 400/3 minus 100/9 minus 1000 over 27. 23, so we've got 2300 over 27 pi, and that gives us 267.617, so I'm going to go for 267.6 centimeters cubed for sig fig. What did they want? Find the position of the value R which corresponds, find the positive value of R, and find the value of V which corresponds. Done. Okay, we will leave it at that for this video.